is no light coming on. Are you with me? So this is how Faraday shows the relationship between voltage and the flux. Hi guys, welcome to today's class. Today we'll be talking about Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction simply shows the relationship between voltage and flux in a circuit. Now when you have voltage directly proportional to rates of change of flux, now when you remove the proportionality sign, E becomes number of turns, rates of change of flux. Now don't forget that this will now lead to E, which is the voltage, and number of turns, then the phi dt, rate of change of flux. So let's go to a simulation. Now let's say we have something like this, just to show Faraday's law of electromagnetic induction. If you look closely, you see that we have a coil whereby it has 4 turns. We have another coil whereby we have just 2 turns. But I just want to work with this first. If you observe, let me take out the voltage. I'm just working with the number of turns, which is the coil and the bulb. If you observe with our magnet, once you pull this in, you'll notice a form of light coming in. So that shows that there is a relationship right here between the voltage and the flux in the coil. So the fact that you have this coming into this place, you can have it that way. Now there's something we should also take note of. If you have a situation whereby the magnetic coil or the magnet itself is moved in the coil such that you stop halfway, you observe that there will be no production of light. So it has to be a constant situation whereby it goes in, because as the magnet goes through the coil, the flux changes in the coil. Let's have a situation whereby we have another. The same thing is applicable to this. Let's test. If the magnet goes through the coil, the light comes on, fine, it's bright to a point. Now if the magnet goes through this, it seems to be brighter here. Why? Because it has about 4 coils here. So the greater the number of turns, the more or the higher the flux in the coil. Now let's add a voltage to it. So when the voltage comes into it, you observe that the fact that you move inside this, there is a deflection right there. But once you move, you stop halfway, you observe that there is no deflection and there is no light coming on. Are you with me? So this is how Faraday shows the relationship between voltage and the flux that in the circuit, the changes of flux which seems to occur in the coil. Now the voltage itself, there is a deflection once the magnet goes through the coil, and of course there are changes in the coil which seems to be that of the flux. And attaching the feed line to this, these are lines of forces of the magnet. So for this you observe that the movement still takes place, which is still very fine, and the same thing is what we observe for this. If you come to this section of it, you observe that because it's just the number of turns there seems to be few, the bulb doesn't seem to be very bright. So because you have more of this, seems to be brighter. And don't forget, if I go fast here, what do you observe? It's more or less like the bulb comes up very bright and stops at the same time. The same thing happens here. Can you see this? But if I do the same for this, Yes, fine. The same thing is applicable, but the bulb is not as bright as that has more coils in it. So this is just to show the relationship between Faraday's the flux and the voltage as regards Faraday's law of electromagnetic induction. Thank you so much, guys.